All right, this is Mr. Wyrick, and I'm going to be taking you through the notes for 312, 313, and 314, and it's 3.2.12, 3.2.13, and 3.2.14 all at the same time. So there's a lot here, but at the same time, there's not a ton of new stuff. So 3.2.12 is proving that a parallelogram is a rectangle. So that's what it says there on the first slide. So on the second slide, it's just going back over all the stuff that makes a parallelogram a parallelogram. The opposite sides are parallel. The opposite sides are also congruent. The diagonals bisect each other. The opposite angles are congruent. And if you put just one diagonal through it, it will create two congruent triangles. And you can prove them angle, side angle, or anything like that to try to get them where you want them to go. So this is stuff that we've already talked about. We already know this. We already have a pretty decent idea about parallelograms. So then we move to slide number 3. And slide number 3 talks about rectangles. Now, rect is like German, and it means like upright or right. And angles are angles. So rectangles literally is just talking about right angles. So it says here on the slide, the following characteristics set rectangles apart. The diagonals are going to be congruent to one another. So aside from just being, hey, these are bisectors of one another, as would happen in every parallelogram, in the rectangle, the diagonals are congruent, and all 4 of the angles are going to be right angles. So we still have the opposite angles that are congruent because it's a parallelogram, but because they are right angles, that's going to make it a rectangle. So we go to that next slide. This is slide number 4, if you're keeping up over there on the left. How do we prove it? Okay. The first thing we need to do is establish that we do have a parallelogram. Like, what's going on that makes this a parallelogram? It's quadrilateral. The opposite angles are congruent. Okay, cool. So the next thing you need to do is find out one of the 2 things that are listed there on the page. If you find a right angle, okay, if we have a parallelogram, we already know the consecutive angles going in either direction are going to be supplementary. They're going to add up to 180 degrees. And we know that the ones in the opposite corners are going to be congruent to one another. So if you find one right angle, all the angles are going to be right angles if you've already established that this is a parallelogram. Okay, then the second thing that you can do, if you can prove that the diagonals are congruent to one another, this is a rectangle. So that takes us through slide number 4. Then slide number 5 is where it tells us this is a 3.2.13 and 3.2.14, proving that you have a rhombus or proving that you have a square. And it says rhombi on there because just like cacti is the plural of cactus, rhombi is the plural of rhombus. Okay, so I had to move my phone so I could see my screen over here. So that's slide number 5, the title of the new part. Slide number 6, again, touches on the same things about parallelograms. We're kind of combining a couple different sets of notes here all at once so that you can pause this video and take your notes. So the characteristics of parallelograms, again, the opposite sides are congruent. The opposite angles are congruent. The diagonals are going to bisect each other. And one diagonal is going to create 2 congruent triangles. That happens in every single parallelogram, no matter what. So for the rhombus, a rhombus is a parallelogram. So you already have to have proven that it's a parallelogram. And what makes it a rhombus? We talked about this the other day. It was on the video from Friday. Talked about it Monday. All the sides are going to be congruent. The diagonals are going to be perpendicular bisectors of one another. So they create 90-degree angles. We have right triangles there. And diagonals are going to bisect the opposite angles, which is a nice thing. On the square, this is slide number 8, if you're following along. The square is a parallelogram. So it has to already have all the properties of parallelograms. Then it has to have the properties of a rhombus. It needs to have all 4 of the sides be congruent, or the diagonals have to meet at a 90-degree angle, okay, like they would in a rhombus. And then it also has to have some kind of property of a rectangle. All the angles have to be right angles, or the diagonals have to be congruent. The things that it would take to prove that a parallelogram further on is a rectangle, okay? So you never really prove if something is a square all by itself. You prove that it's a parallelogram, and then from the parallelogram you prove that it's a rhombus, or from the parallelogram you prove that it is a rectangle. So if it is both a rhombus and a rectangle, then we know that it's a square, okay? So if you get on and they give you like points on the graph, and you're trying to plot those points, and you find out it's 3 over and 4 down, 3 over, or 3 down and 4 over, or whatever, and it's 3 and 4 to every single point on there, then we know that those opposite sides are going to be parallel. We know that the opposite sides are going to be congruent, so we end up with a parallelogram. We see that all 4 sides are the same, so it's all 4 sides are the same, so we end up with a rhombus there. And then we find out that those are right angles that it's meeting at. We have opposite reciprocal slopes on the adjacent sides. So that means it's a right angle. So we have a rectangle. So we have the parallelogram, we have the rhombus, we have the rectangle, and because we have all 3 of those things, we have a square. On slide number 9, this is kind of important. This is the stuff that's going to show up on Delta Math for what it is that you have to do on the Delta Math assignment that we're going to have today to prove. So it sounds a little different. It says on the parallelogram, the defining feature is the opposite sides are parallel. So you need to prove it by showing that the opposite sides are parallel. They have the same slope. Showing that the opposite sides are equal measure, or by showing that one pair of opposite sides is parallel and of equal measure, or congruent, okay? It doesn't give you the option of the angles because it doesn't give you a way to measure the angles, so that one's kind of left off. It doesn't really say anything about the diagonals here because, again, on the Delta Math, it's not really going to give you the option of messing with the diagonals, okay? Then it says the rhombus, all sides equal measure. That's the only way you can prove it here. You can't say, oh, these diagonals are going to meet at a 90-degree angle. They're not going to let you do that. The rectangle has all 4 right angles, so you can see the perpendicular slopes, the opposite reciprocal slopes. Make sure you check back. You know what that's talking about there. And then the square. All the sides are the same, and we have all 4 of the angles being right angles. Remember, if you just have 2, if you haven't already proven that it's a parallelogram, one right angle is not enough. It has to be a parallelogram, and then if you find the one angle is a right angle, it's going to be enough, okay? With Delta Math, you may have to finagle it a little bit. I'm going to make a second video going over the Delta Math, so hopefully this is enough to get you through the notes. The last slide there just says today's assignment. It's Delta Math. Don't do it for homework. Make sure that you just work on it during class, maybe during flex, or if you get a chance during other classes, try to get some stuff done. I'm going to come back on Wednesday. We're going to have kind of a work day to go over some of this stuff. Probably review Thursday, maybe test on Friday. It depends on if I think I'm going to have a sub that can handle giving you guys a test, or if it's going to be too much of a hassle and we'll take the test next week. Okay, so we'll get that figured out when we get there. But for today, make sure you do all these notes and start on that Delta Math, and we'll work on that for a couple days.